Hello and welcome to the Unnamed Reverse Engineering Podcast. I'm your co-host Alvaro, and with me today is...
Hey, I'm Jen.
And our guest is Stacksmashing, Thomas Roth, aka Stacksmashing. I got it backwards.
Why can't it be backwards? Why can't it be Thomas Roth, aka
Thomas Roth?
I'll take both.
Okay, great.
Hey.
Good to see you again.
Yeah, good to see and hear you again.
Yeah,
nice
we caught up at DEF CON a few weeks ago and finally met in person, which is always fun.
Yeah,
but
absolutely.
Yeah, and you told us in person a bunch of cool stuff you've been up to, but we want everyone else to know about it. So just, I guess, really quick, in case people haven't heard about you, can you just tell us really quick who you are?
Sure, yeah. I'm an embedded security researcher, I would say. So a lot of hardware stuff, a lot of firmware stuff. I try to keep away from high-level stuff, so less of that. And yeah, I also run a YouTube channel called Stacksmashing, which, has a couple of my hardware projects and my hacks and so on it. So yeah.
And for those of you who haven't heard him before, you can go back to episode 63 where we first talked with him. You get caught up, so shouldn't be a big deal.
Yeah, just pause, go listen, come back. All right, welcome back, everybody.
Don't forget to subscribe and hit that bell and whatever.
Oh yeah, well, definitely
subscribe.
Hit the bell on YouTube.
Wait, before we go further, do you guys know that young children think that subscribe is
a thing?
How to say goodbye?
That's awesome.
I also saw that if you say in your video subscribe or hit the bell, YouTube will actually highlight the button. Like they're actually doing...
Yes. It'll do a little ding thing.
Yeah.
I didn't know. I never tried. So
it might be
clearly you don't subscribe to a lot of things. You know what? If you go to our YouTube channel, which just plays... Yeah, we do. We have a YouTube channel. Every time we upload, it automatically just puts the podcast there with our logo, because that's what the kids want. And you don't have to see our faces, thank God.
Yeah, we don't record the faces.
But you can go over there and practice the ding thing by...
Oh, yeah, we did say like and subscribe. So we'll see. Anyway.
Let's find out.
So... we were going to ask you what you've been up to since the last time, but I guess we'll just go topic by topic because there's so much. Last time we talked about JTAG on iPhones with Lightning and all of your kind of research and investigation and making a debugger for iPhone. And then iPhone came and got rid of Lightning. So what was that?
Yeah, that was fun.
Was that?
My plan was to just completely ignore that, but unfortunately YouTube has a commenting function, and so YouTube comments wouldn't stop asking about the iPhone 15. And so I decided to, pre-order the iPhone 15 and pre-ordered a couple of things and thought I would just try to get JTAG on the iPhone, which I assumed wouldn't be too difficult. Mainly because other people that we will get to did a lot of other work that made it drastically easier to do. And so, yeah, I essentially tried to... So we call the first cable... all these Apple debugging cables are named after monkeys or apes. And so it's Kong cable, Kanzi cable. And we called ours Tamarin cable, which is the monkey with a very nice mustache. And so it's the way to go. And so, yeah, we did Tamarin cable. Then the iPhone 15 came out, which uses USB-C. And then basically all their work was useless and we had to start over.
And I mean, I guess a few of they got rid of everything now. Just some headphones might be still Lightning, but...
So they just start clean over, which, I mean, if I remember, so going from that really, really big cable back in iPod days,
I think, or
yeah, whatever that was,
connector,
and then to the Lightning, like it seemed like.
I mean, it was in 2012. It was in 2012 that the switch happened.
Yeah, but my understanding, and I may be completely wrong, is like underlying that. I think you had commented like there's that little chip there, and I assume that's just the M5 chip that's in there, so it can talk to the iPhone. Like it just seemed like
there's an auth chip on there. Yeah.
Yes, yeah, that's the auth chip, and it talks in a particular way. But what surprised me, I guess, was that. Are you saying that they just could look? We're decoupling ourselves entirely from that and starting over from scratch?
Yeah, essentially. I guess I wasn't aware of this until the iPhone 15 either, because I never actually looked at what Apple does on USB-C.
Mm-hmm.
And then with the iPhone 15, I eventually realized, hey, there's the iPad that already has USB-C, and all the MacBooks already have USB-C, and they also have Apple Silicon, and so on and so forth. And it turns out that people already figured everything out, essentially. So it turns out that when you have a MacBook, then the back left USB-C port is actually a special port that you can use to debug other Macs and iPhones and so on and so forth. And so basically when you have a USB device, it does all that fancy power delivery negotiation, right? Like to determine, I want, 12 volts and 2 amps or whatever. And as part of that communication, you can also implement custom commands via something called VDM, like vendor-defined messages. And it turns out that Apple essentially uses VDMs to be able to reconfigure USB-C ports on devices. And so USB-C has like, a million pins. And you can essentially say that, on these 2 pins that are normally available on USB 3 cables, I now want to have a serial console and so on. And people figured all of this out already. And so essentially the T8012 dev team, the Asahi Linux people, and so on, they all looked at this and they figured out even how to, from user space on macOS, send these commands via a chip in the MacBook that's connected to the USB-C port. And then you can, reboot the connected Mac, reboot the connected iPad, and even get like UART and so on and so forth. And so people figured all of that out, and so I just assumed that it would be the same on the iPhone 15, essentially.
And was it?
Yeah, it was. So essentially, basically, there's a lot of different projects there. So one is that essentially the T8012 dev team, they opened up a MacBook and they found that there's a chip connected to the USB-C port called the host port microcontroller, and we call that chip the ACE2. And that ACE2 essentially controls the entire power delivery communication.
And that's, I think that's what you were referencing as the on the left side and the one furthest away
back
from
left.
Because I'm looking at my MacBook right now. Is there a particular version of the MacBook onward where this is supported, or is it all of them?
I think it's starting with the Intel Macs with T2 chip, and so some of this research is years old. Like it's been around for quite a while. And so the T8012 dev team found out that this controller essentially is there, and mainly they found out that it has debug enabled and that you can just solder some wires into your MacBook and dump the firmware of that chip. And that way they found out that Apple implements these custom vendor-defined messages commands that let you switch essentially the USB-C port to be, a serial port and fancy stuff like that. Okay. And they did that on Intel Mac like years ago.
So they basically did it from the opposite side of where you came in, right? You were measuring signals on Lightning. They start looking at the source code on Mac OS and then the firmware on the chip, and figure out that was there.
Yeah, essentially. And then the Asahi Linux people actually, I think, built a tool called Mac VDM tool. And that tool lets you, from user space on macOS, use the ACE2 to send vendor-defined messages to another device, because these VDMs, they are not regular USB.
What does VDM stand for?
Vendor-defined messages.
Yes. Okay, thank you.
And so it's just like custom communication over the charging protocol, essentially. And they essentially found that you can do this from software and then send out, reboot your Mac and get the serial boot log, which is really, really useful when you try to port Linux to a machine that not so much about. And so that exists. And then Marc Zunier, which is also, I think, one of the kernel developers for that kind of stuff, he built a tool, like a hardware tool for it, because currently you can only do it from Mac to Mac, essentially. And he built something he called the central scrutinizer, which uses a Pico to essentially, a Pico plus a USB-C controller to essentially send those VDMs to a Mac, and then you can reboot the Mac at the serial output without having a Mac yourself. And so you just have a small USB dongle and so on and so forth. And so I just assumed that somehow we can use this functionality to, just get JTAG on some pins. And so I pre-ordered the iPhone, pre-ordered some PCBs of this central scrutinizer, put it together and so on and so forth, and then started fiddling around with the iPhone 15.
And if I remember correctly, most phones are locked. So even if you have JTAG, you can't really do much, right? With a production device.
Yeah, exactly. So essentially what happened is I got the central scrutinizer. I played around with it for a bit. I found out that it works on the iPhone 15 after doing a slight hardware modification. So I should preface this, like, I know nothing about USB-C. So this was my first time dealing with USB-C power delivery. And so I was just stabbing in the dark to somehow get this working. But I found that I have to have a USB-C switch to essentially repower the phone for the central scrutinizer to work. And so I did like a small hardware mod. And then I essentially was able to, reboot the phone, get the serial output and so on. But that didn't really give me JTAG yet. But in the documentation by the Asahi Linux guys on USB PD on MacBooks, at the very bottom of this, 6-page document, there's a small note. Oh, there's this command 0206 that when we send it, pulls the pins up with a very slight pull up. And there's a good chance that this is SWD, but nobody seems to have openly verified that it is. And so I just essentially patched up the central scrutinizer code to send that command. I hooked up actually a J-Link to the pins on the central scrutinizer. And then, I had SWD and I could enumerate the chip. Like I could see, SWD is active. But, the iPhone is a production device. It's locked. And so essentially I had JTAG, but it was completely useless.
So you have to basically wait for another, was it checkra1n or one of these exploits that lets you disable the lock before you can use it?
Yeah, exactly. Or, if I think there are like multiple levels of engineering iPhones. And if you get one that's completely open, then theoretically you could use this. However, what was cool is that on the iPhone 15 and on the, I think, Mac M3, starting with the Pro and Max, you actually can get access to some different internal signals on the computer. So instead of just getting like serial and JTAG and so on out there, you also can get access to the SPMI bus and so on and so forth. And so while JTAG was useless, we still could like explore a couple of cool buses on there. And then we decided to essentially design another board. We called it Tamarin C, which is essentially just a bus explorer for USB-C Apple devices. And then, I checked what actually changed on the hardware side. And on the iPhone 15 and on the M3 Pro and Max, the ACE 2 that we had on previous Macs, where all of this was discovered on and where we had a firmware dump, was replaced with a new chip called the ACE 3. And so that one is fairly interesting because if you think about it, if you have a chip between your USB port on your phone and the actual SoC, if you can fiddle with all of that communication, you can actually do a couple of really interesting things, right? Like if you, for example, have another boot ROM exploit like Checkmate, right, which was exploitable via USB. Imagine if you could just run that exploit on the controller that sits on the USB port in the phone, and you would gain, persistence for free, essentially.
Oh, so the ACE 3 is on the iPhone?
Yes, it's on the iPhone and on the M3 Pro and Max.
Can we go back for 1 second?
Yeah,
okay,
sure.
So for you were saying about the differences between ACE 2 and ACE 3. It sounded like one thing was like, hey, in the ACE 3, it seems like it has like a light pull up to handle USB-C. Is there any other big deltas there in functionality? Or is it outside of that, is it strictly like, hey, I'm just marking myself as I'm ACE 3?
So the Ace 2 already had like SWD and so on. And so we essentially you can use it to gain access to like some I2C buses and so on. But then, and this is on all Macs up to the M3 Pro. And then on the iPhone 15, it behaved very different in a lot of cases from the documentation. And then it turns out that instead of an Ace 2, like they had, for example, also in the iPad, they put an Ace 3 in the iPhone, which is a new chip. And so this is kind of interesting because the T8012 dev team managed to dump the Ace 2, the firmware of it. And it was known that it's just essentially a rebranded TI chip with essentially, a custom ROM mask.
Yeah.
And it's super interesting because it boots internally, but then it loads patches for its internal flash from this external flash chip. And so essentially the flash doesn't actually contain firmware, it just contains patches for the internal function.
It's kind of BIOS-y in a way.
It's super, super annoying once you try to reverse it, because essentially any call to a function is like 3 times indirect. And so like your call graph will look terrible if you don't, optimize that away. And so given that people managed to dump the Ace 2, I thought it would be fun to try to dump the Ace 3. And that's where
trivial, perhaps.
That was kind of the hope. And so actually on Christmas, I screwed open, like just before the CCC talk about the iPhone 15, essentially, I opened my MacBook and dumped the Ace 2. Okay. And I like by soldering to it and like just dumped the firmware. And I checked some of the schematics that you can find online, and I found that the SWD pins that go to the Ace 2 also go to the SoC. And so it looked like you could actually debug the Ace 2 not just by opening the case and doing like hardware stuff, but that it's actually also connected to the GPIOs on the SoC.
Can you chain like that in SWD?
You can go both ways sometimes.
Yeah, but so I know JTAG definitely. There's this idea of chaining, and you need to specify which device on the chain that you're talking to. I didn't have that awareness in SWD.
No, it can't. You can't.
It can't. So okay. Essentially,
thank you. What you see on the schematic is like you have the SWD port of the processor, and it goes to some pins on the Ace 2. But then the SWD pins of the Ace 2 goes to some GPIOs on the processor.
Okay, so it could theoretically be passed through, but more than likely is not.
So they both have JTAG into each other, basically.
Yeah.
Yes.
It's just one at a time.
You can.
How do you determine who's how do you determine who's the main?
Who's the captain
in that way? Well, yeah. You know what? I appreciate that everyone's trying to avoid the traditional terms that we use, but it is becoming very hilarious.
Yeah, in this case, it's just literally 2 different buses, right? So it's like completely different traces even.
Okay.
And I thought, hey, maybe I can control those from software and, just debug. And so thankfully, the Asahi Linux guys already built a driver to talk to the GPIOs from Linux, because they probably needed to enable the backlight or whatever. And so I actually loaded a kernel module into my Mac that lets me write to random kernel memory. It's called IOKernel RW by Sigusa. And then I essentially wrote an application that lets me toggle those IOs, and started through the macOS kernel, started bit banging SWD essentially. And so that way I was able to dump the Ace 2 from software, and I also was able to patch out the update validation. And so essentially you can update the firmware of the chip from macOS using a tool called USB-C firmware flasher. But that one does an RSA signature
so it has to be signed, basically. Yeah.
But if you get code execution on the chip, you can override the patches in the external flash, and it turns out that the RSA signature check for updates can be patched out.
Can be a no out. Oh.
Well, probably in case they ever have to update,
or they need to bypass it.
Yeah.
Because it's bad firmware.
So this is on a Mac from the host processor. And are you doing this for macOS, or do you drop down to Asahi, or do you use Asahi to do stuff?
I did this from macOS. And so eventually this was working, and and this is all on the Ace 2, right? Like on the old MacBook essentially. But I was hoping that the ACE3 would just be like a tiny iteration on top of this, right? And so we did I dumped the firmware on the ACE2, found this vulnerability essentially that lets me disable secure boot persistently. Mm-hmm. And now I had the ACE2 essentially compromised. Like I could essentially, even if I did a full restore, the ACE2 was still compromised. But the ACE2 is not a really powerful processor, and so you can't really do anything interesting. Okay. And so I wanted to try this on a new device with an ACE3, right? Like the iPhone 15 or the MacBook. But to do this on the iPhone 15, you would need a jailbreak first, which is fairly difficult to come by.
Very expensive.
Yeah. Okay. I mean, sorry. Okay, so given the fact that, like, yes, if you really wanted to do this, like, you would probably need to procure several expensive items, which may break, and you might have to get another thing at least $1,500 a pop. So,
yes.
Going back. Okay, so let's say I forget the iPhone for a second. I just wanted to work on my MacBook for the moment. What is the minimal number of MacBooks I would need to do this type of exploration?
So, I mean,
is it one? And I'm just,
yes,
it's like I'm doing surgery on myself, basically.
That's always, yes, that's how I did it, to be honest.
Okay,
and so,
that's what I wanted to confirm.
Yeah, so I actually, I essentially just used my MacBook, and I first dumped it physically because I was fairly confident in my soldering, and then I found this way of dumping it via SWD from the SoC.
Okay.
Which required fiddling with the kernel and so on and so forth. But then, yeah, so I had all of that, but then, ACE2 is on the way out. It's boring. It's not very powerful. But on the ACE3, it's all a bit different, because on the iPhone, when you actually go into DFU, the DFU mode, it's called port DFU, is actually running on the ACE3. So the ACE3 is running like a full USB stack and so on and so forth, and it seems much more powerful.
How big is this thing?
Yeah,
how big is ACE3? Like, what is the memory on it? Well, okay, a couple things that you have not mentioned. Okay, you briefly mentioned that it was a TI chip, but you didn't necessarily say which one. Maybe
like a
which
Cortex
class
M or Cortex A or a.
Yeah, it definitely does not feel like a CC something, one of their wireless modules for an MCU, but
it's a Cortex M essentially. Okay. It feels like a Cortex M. It's just like ARM thumb on there, and so it's very very easy to reverse essentially. Super trivial to look at. Okay. But then for the essentially, because the ACE2 was so open and was just a rebranded TI chip, I was hoping that the ACE3 would just be the same. Like I could just open up, I don't know, a MacBook or an iPhone and dump it. Or because I had the software thing, I could just do it from software and never open up the case. And so I ordered an M3 Pro /Max on Amazon, like a MacBook, because on the MacBook, you have like, I think 3 or so ACE controllers, and you have, multiple chances to get it right or to brick it. And it arrived.
Wait, how many chances do you have before you brick it?
A couple, hopefully. And so essentially,
I'm going through this, and I'm having this chat back and forth, and you can see it while you're discussing this, and I'm like, oh, I've been thinking about getting a MacBook. Maybe this is going to change my plans, and now I'm flip-flopping again. Which is
So the ACE3 turns out is like, it's a completely new chip. It's I think it's even like BGA or so. It's much even physically larger than the previous one. It again has like an external flash. And I opened this up, and I checked on iFixit the pictures first, and it looked like,
of course,
we have the same debug connectors. And for me, I was confident I will, just use my software way of trying this.
Yeah.
But the problem is there are no schematics yet.
So you don't know which GPIOs.
Exactly. And so I decided I would just brute force it. And so I just loaded a kernel module and just started writing to random GPIOs in memory, which, cause resets, or sometimes your screen turns off, or this and that. Like random stuff just happens. And so
did you find any fun commands or fun GPIOs? Like, oops, no OS anymore on this machine?
I was worried a couple of times that I actually bricked the machine, to be completely honest. And so, but eventually I was pretty confident that I found the right IOs. Okay. And then I actually opened up the machine and put some probes on the debugging ports. And I could see that, I'm talking to the right pins, but SWD was locked. even with a dedicated machine, Ace 3, no bueno, no luck. They
on
seem
the
to have on the MacBook. Yes.
Oh, so they locked SWD on the Ace on the MacBook.
Yes. Yeah, exactly. And so yeah, that wasn't so nice. But and at that point, it's like, okay, do I give up?
It seems completely reasonable to me.
Yeah, so
sounds like a challenge.
Yeah, do I give up and send this back to Amazon, or do I, try to go down that whole rabbit hole? and I figured, okay, I will, dump the flash, and then I dumped the flash, and it was the same. It was just like, again, like Cortex M patches loaded from the flash. And so I thought, yeah, I'll just try to, modify the version number in the external flash.
This is a side question. What exactly is Amazon's return policy for what all you did to that machine? We don't know.
I don't know, because
you didn't return
I didn't send it back, but for the software,
but I have to say, like what the hell is, like, it's
not working.
Like, what the hell is this?
There's like I think the USB-C port is broken.
Well, depending on which one you have, like, you may have anywhere from 1 to 3 more.
Yes, but so I tried to reflash, like I changed like a single bit in the flash contents, and so from software I can restart the chip, and so I restart the chip, it doesn't come up. But even worse, once one Ace doesn't boot anymore, all others stop charging the MacBook. And so I essentially had 8 hours to recover the MacBook and to recover the Ace, because otherwise the machine would be dead, and that's it. And so I tried to flip a bit, restart it. It wouldn't come up again. They do some kind of firmware validation, started reverse engineering, parts of whatever I saw in that external flash. And there I found like random CRCs and so on. And I started, filling those CRCs, flashing it back, and so on and so forth. But I couldn't get it to boot. And so I even wrote like a fuzzer for the commands that you can send from macOS to it and so forth. But eventually I was essentially at a dead end. I had this MacBook. I could do anything with the Ace 3. And I essentially was just in a situation where I really wanted to hack this chip now, because I already spent 30, 40 hours on it.
But you can't go back now.
Exactly. And so I was like, okay, how can I actually get into this thing if, my software skills are not good enough, my SWD is locked, they do whatever validation on the flash. And so I thought I would just try to, in the $3,500 MacBook Pro, do fault injection to somehow get my firmware to boot. And
duh.
Yeah, so I thought
you don't get more conservative. You
double down.
Yeah, exactly. And so if you've never done FI, it has a high tendency of bricking chips, especially if you do, EMFI.
Yeah.
And so I was thinking, do I do voltage fault injection? But then I don't know on which pin is the actual power supply of the chip, because I know nothing about the chip.
You don't have a schematic. You don't have a data sheet.
Nothing. And so I figured, I would just do EMFI instead. And so EMFI is just injecting, 400 volts through a coil into the chip, which, what could possibly go wrong?
Except if that chip's specifically supposed to be resilient to that, but I don't think that's the case here.
This is with like a chip shouter?
Yeah, exactly, with a chip shouter. And so and the problem is you need to time your glitch, right? Like you need to figure out where do you actually do the attack. And the big problem there was, like, I know nothing about the chip. I just know that it doesn't boot, and that's essentially it. And so I thought, well, I found like 3 CRCs, and maybe I can find a side channel to see where in time the chip actually fails to boot. And so I essentially used a near field probe connected to an SDR to measure the software-defined radio, basically just a digital radio, to measure the chip emissions as it boots. And then I essentially tried to set all CRCs to be wrong, and then I corrected them one by one. And I could actually see in the radio spectrum where in time the boot would fail with each corrected CRC. And so at the end, I had like one point in time where I was like, this is where currently the boot seems to fail. And so I just started glitching there. And so so that's kind of fun because the machine was attacking itself because I had to reboot the ACE3, see if it boots, right? And I can only do that on that host.
Mm-hmm.
And then I would reboot, and then I would glitch, see if I was successful, and so the machine was glitching itself.
And you were controlling the glitcher from that machine?
Yes, I had to.
That's crazy. Like, I just want to, and let me make sure I'm very clear on this. Still the 8-hour timeline.
Yes.
Okay.
And so, yeah.
So I have thoughts on this.
In between, it's essentially like, okay, I have 8 hours to get this attack working, and then the battery will be out. Then I have to reflash the ACE via,
so you can charge it.
So I could charge it again, and then I had to re-attack it, and so on and so forth. But after hours and hours and hours, I actually succeeded in glitching it, and so it would boot, and I had a single bit flipped, and so I could change the version number. So, hundreds of hours of work completely wasted because I only changed the version number of the ACE3. But now I knew that I could, load a modified patch. But it's just patches. I don't know when they are executed.
Yeah.
And so it's like,
or the control of them, for that matter.
Yeah, exactly. But then I found, because I had the ACE2 firmware and I reversed it, I found overlaps in the patches between ACE2 and ACE3. And I found a function that I could call from the host OS, essentially. And then, redid this, hours and hours of glitching and so on. We will link the talk in the show notes, I guess, that goes into much more detail. But eventually I got codecsec on it and was able to dump the firmware like 4 bytes at a time, which took unfortunately more than one charge. So I had to re-glitch it again. So
just some thoughts here. Have you considered taking this story and selling it to Hollywood? Hear me out here. Because what you basically inadvertently did was you created a bomb disposal challenge.
Diffusal
challenge here with that timeline. And then, of course, like all movies and all, action-packed movie. And I think this is in general for any movie. You don't have a movie unless somebody makes a poor choice. And
what was mine?
You made a few. I mean, they ended up working out.
I mean, but that's the point of like all American movies in particular.
Yeah, I learned
keep like doubling down, and then like somehow we won.
I learned a lot about the sunken cost fallacy during this.
But you got away with it. That's not...
Well, yeah, that's not learning the sunken cost. I mean, it's very nice that you said, like, at the end, it comes up at the end. The end is like, Thomas learned a lot about the sunken cost fallacy. But I don't think where will he apply it next?
Yeah. So then you're the first person to fully get the ACE3...
dumped, essentially. Yeah.
Nice.
So I got codecsec on it, but it's, like you would never attack a device this way, right? And it's also, I don't have persistence, right? Like as soon as the power is gone. And so I actually had this MacBook running for a month, just like half open with an iPad charger in between the screens so that it wouldn't go to sleep, and caffeinate and so on running, just so I could like just peek and poke in memory and so on.
Yeah.
And so, that was the ACE3. And that was actually my DEF CON talk, essentially the story of like how iPhone 15 and getting JTAG, which was like a thing of like a few hours, sidetracked me into this hundreds of hours project.
that seems to be
the ACE3
recurring in your project. And so, I mean, now that you have the ACE3 firmware, then you could, in theory, find a vulnerability that you could use on the iPhone, or you could use on...
The big problem is that, so yes, we can do emulation and so on with it, and I did a bit of it. But to be completely honest, after I had it glitched and it worked, I completely lost interest.
Yeah, I mean, that's what you wanted, right? You wanted to get it, and now if someone else wants to do it...
Yep.
Don't let that get out. Well, I guess here, okay, my question is like, do we really anticipate that? Okay, I'm fully willing to believe that ACE3 is going to be similar on the iPhone 15. Fine. What I'm wondering a little bit is like, in terms of like, is there anything else that's going to be transferable internal on the iPhone 15?
So I reverse engineered some of the iPhone 15 update packages. And again, I don't have access to a jailbroken iPhone 15, so I can't even test my theory. But
those aren't on Amazon?
Unfortunately not yet. They should be, but
there is a invite only program, I think, where some people maybe
which only gives you the iPhone 14, not the 15. Oh. So the SRD is always 1 year behind, and so for hardware, it's not actually.
So
great.
Next week or next month.
Yes.
Here's hoping, and so because then we if I look at the updater correctly, it looks like they actually use SWD on the iPhone 15 to access the Ace 3. So it seems like SWD is activated there, but I can't test that without, opening up an iPhone 15 and doing like very, very tiny soldering, which is
and those boards are no joke.
Yeah, so
going back to not consumer electronics, I laugh a lot when people are like, "Oh, it's a really tough solder. It's really tight." And I'm looking, I'm like, "You have no idea."
Yep.
No idea.
Yeah, and so managed to hack the Ace 3, and then now I actually made it very cheap because we can now just use the PQMP, which is like a $60 fault injection tool to do it, and everything is running, like the triggering and so on is running on there.
Is that also by NUAE, by Colin?
Yeah, exactly. Colin built the PQMP. I wrote the C firmware for it, and so now you can do it for very cheap.
And we'll have links to all these things, of course.
Yeah, I just love I love the collaboration across like all the different areas of expertise. It always makes my heart feel warm.
And Colin's super nice. So
oh gosh, yes.
Yeah. I was super Nerd Snipe when I met him the first time because it's like this.
That was the one time you were Nerd Snipe.
And then he was so nice. Colin is awesome.
And okay, so we've been talking about the Ace 2, Ace 3, DEF CON talk. Jen and I were both there. It was a lot of fun. And you gave me your business card, which happens to be a circuit board that can be used to defeat BitLocker, which is a little other project you were working on. Is it
complete?
No, I have to add some.
Provide your own.
Yeah.
So can you tell us a little bit about that? Because it might have almost been useful during the CrowdStrike fund recently.
That's why I made it my business card, actually. And so my essentially there's this issue with BitLocker when run in TPM mode, which is, by the way, the default. Like if you enable BitLocker on a Windows machine that has a TPM, it will just be in TPM only mode. And to activate the pin, you either have to go to the command line or whatever. And so by default, BitLocker will encrypt your machine with TPM. And TPM is awesome, right? It's trusted platform module. And if you read the description of what a TPM does, it promises you security everywhere and so on. And so according to the documentation and so on, it's awesome. It's amazing. According to Microsoft, it's like the most secure way to run BitLocker. Unfortunately, the communication between the TPM and the processor is unencrypted. And so if you have a machine with a discrete TPM, you essentially have like this unencrypted bus. And now some CPUs have like integrated TPMs and so on and so forth. Lots of caveats here. But essentially, if you just enable BitLocker, the key can be sniffed. And so when you find, a notebook from someone that has TPM only BitLocker enabled, you can sniff that key. And this is true for a long time. And so I knew this for a long time. Everyone knew this for a long time. And so I assumed that eventually this was fixed, right? Because there's like TPM 2.0, there's TPM this, that, and they just had a lot of time to do something about this. And so a friend of mine, Pascal, was giving a training at Black Hat on TPM attacks. I'm Pascal, is this still the same as 10 years ago? He's like, yes, and no way. And so, and then I read the Microsoft documentation. An attacker with time and skill and so on. And as you just hear, I have a lot of time, unfortunately. I could bypass this.
Clearly.
But I don't know about.
Well, if you're not encumbered with other things like Ace 3.
And so I thought it would be fun to just take this ad absurdum and make like the fastest attack on BitLocker that I could come up with. And so it turns out that on a lot of notebooks, you can kind of just remove the backplate, and then there will be a connector or maybe even the chip itself somewhere that lets you access the TPM bus, which is LPC or SPI in most cases. And the buses run relatively quickly, and so normally you would need, a higher performance logic analyzer, like not a $10 one, but 100 or 1,000 upwards and so on. And I didn't want to do that. Like I wanted to go with like the cheapest way possible, just to get the point home of like, this is just a bad idea. And so again, this attack has been known for years. People have done it forever. And so I didn't invent the attack in any way. I just essentially I grabbed a Lenovo laptop I had laying around, which had a TPM. I opened it up. I found that there's a connector that, actually has the TPM bus on it, like the LPC bus, but in production devices, they don't place a resistor, and so you don't have a clock signal to read the signals essentially, but you can just do your own. And then I found that other people found the exact same pins and so on and so forth. But then I thought it would be fun to use a Raspberry Pi Pico with the PIO thing and essentially build the sniffer completely contained in the Pico, and then just have a couple of needle probes. And so you just open up the laptop, press down the adapter, turn on the laptop, and then it sniffs the BitLocker key. And so I built this, and I made like a video with the iPhone timing, like running a stopwatch, just like screwing it open, pulling down, and then I just posted, I think, like TPM sniffing any percent speedrun 42 seconds or something. And that kind of blew up on Twitter and so on. And then made a video about it, just like describing the thing. And somehow this, 10 or so year old attack, probably even more, gained a lot of, popularity because of how easy it was to do. And now people build like SPI support and so on for that adapter. And now there's actually a nice small solution to sniff TPM keys for very, very cheap, which is kind of fun. Yeah.
Because I mean, the whole point of BitLocker is to encrypt your hard drive. So if someone has physical access, they can't just take the hard drive out and read it, right? But if they can just take it out, sniff it, then take the hard drive out, but we already have the key. And I feel like, I mean, there's ways they could fix this, right? You could do negotiate a key. Like there's a way to negotiate a key over an open channel securely. And then share that. But
I mean, it's like so long later now, like they should have done something to fix it, right? And I know,
Can I depress you guys further? Because like when we're going, and I put the link in here. I'll put the link in the like I knew somebody who worked on the cold boot attack, and this was like, gosh, was this 2004? I don't remember what year.
Oh, is this freezing the RAM?
Yes, which also exposed the same type of like you can get the key as long as you kind of keep it cold before it like the caps to dissipate. But it's been there like forever. But I would say just in general, and maybe you can fill this in further, Windows x86 platform is built upon backwards compatibility and legacy, and therefore like I feel like that's almost all of the reason
the weakest link.
I mean, now they do like FTPM where the TPM is in your CPU and so on, but a lot of business laptops still have this dedicated TPM. What I don't understand is
expensive.
But you can enable the pin, right? And then suddenly it becomes more secure. Or even in my opinion,
like you have to put in a password to unlock the TPM.
Yeah, exactly. And that like enabling that option for end users is essentially impossible. Like you go to the CLI and so on and fiddle around there.
Yeah.
And also like just give me a warning. Like the documentation on top of the BitLocker TPM should be like, by the way, this is freaking stupid. Don't use it without a pin or a password, right? But instead, it's like on another page at the very bottom, it says an attacker might also be able to do this with less skill. And it's like, this is not how you are open about security, and like just expose it in the UI. Let me set a password, or let me disable TPM and just use a password, because I mean, this way it's completely useless to me.
The threat model is kind of twisted, right? Because the people who care about
you mean obscurity?
Well, no, just like the only folks who would want to protect like your laptop from someone who might take it and want to break in, those are the ones that need to be locking it down like 3 times, not to be convenient. No, you need to put a password. You maybe need to put another like it's like, yes, convenience and security don't go hand in hand, but the default should not be the insecure. I don't know.
Or there should be a warning, right? Like I mean, it's not
definitely.
like Windows doesn't already give you enough warnings, and so
I mean, I'm just going to throw this out there. Maybe it's because the three of us don't speak the subtle, nuanced language of vagueness, and we're really used to
directness,
right? Directness, and because of that, we miss those subtle cues that would indicate to us the danger. Because nobody wants to panic anybody, but there are these underlying concerns that have yet to be addressed that you may want to proactively address.
On the topic,
and you can see like the IT,
as opposed to holy crap.
No, but I mean, I get it. Like the IT department doesn't want to be having to back up the extra key that way when somebody forgets their password. Oh, I can't unlock.
But Microsoft does that backup for you.
Yeah.
No. So like when you activate it, when you
activate Windows.
Oh my God, when you activate Windows and use and actually log in with your Microsoft whatever account, which I was like, God, why do I need to tie this? But it will push that key up to your
especially
account.
In a corporate environment.
Yeah. It's not even a corporate environment, but it like pushed it up for me, and then like I needed to use it. God damn, I hate having to enter it.
Yeah.
It's so long. It's so rote.
But what's interesting
there.
Because I got so many comments, oh, this is not a problem in the real world because everyone enables PIN. I'm like, okay, like tell me without looking it up how to enable the PIN. Step 1.
The fact that we still need to tell people to do 2-factor authentication, and you think that
also like so now a lot of the big companies in Germany where I live, I checked and a lot of them don't have PIN enabled, and they are all like, I got so many emails from people who either need help because they didn't even know BitLocker was enabled and they lost the key, and other companies that needed help with enabling it. It was kind of sad. So and I on the topic of being subtle, I started giving out my business key at the business card at the Microsoft party at Black Hat. So until I noticed that might not be appropriate.
Did you have your laptop with you?
The MacBook?
Yeah.
It sounds like you were holding your own competition unintentionally.
But so mentioned Black Hat. I'm going to go back to DEF CON.
Okay, great.
You were there. You gave a talk, but as you were telling us before we started recording, that was the least of your worries during DEF CON. You had a whole other thing going on. Can you tell us about that?
Yeah, what's that?
Sure. Yeah. So couple of things essentially. So we so Life Overflow and me, we actually funded a company together called Hextree.io, where we try to teach people IT security topics that we are interested in. So it's like a traditional online learning platform, but we try to cut everything down into micro courses. So we like very concise videos, we like very well cut and produced videos, and so we try to build trainings that are very engaging and very hands-on with a lot of capture the flag style challenges and so on and so forth. And we try to do this on topics that interest us, right? And so for me, that's reverse engineering and hardware attacks and so on, and often topics that we feel are undercovered by others, and again where we feel, because of our different style of we come from YouTube and then do courses and not vice versa, I guess. We try to be a bit different there. And so one of the cool things we got to do was we actually got a booth at the Embedded Systems Village at DEF CON. And so the Embedded Systems Village is a 501c nonprofit. And so we also, like, this was not a sales show in any way, but instead we basically had hardware with us and people could learn to do fault injection at our booth. And so we estimate that we probably enable like 150 people to do their first fault injection attack. And on day 0, like on the first day of DEF CON, let's say there were still some bugs to be found and fixed in everything that we did. But overall, that was just super cool. Like we had the booth and we could, like, people could just replicate the AirTag attack essentially. So I did the AirTag glitch a couple of years ago, which is just limited results and a 52 glitch. And so to make that easy for people to reproduce, we built what we call the glitch tag, which is essentially a tiny key finder size PCB that has the same chip as the AirTag, but everything a bit more accessible. So you can just hook it up to our fault injection tool, and then you can essentially reproduce the attack. And all of that stuff is open source and open hardware and so on. And so it was really cool to see a lot of people do their first fault injection attack, essentially.
Yeah, just so folks have a picture, you had like a booth, and then you had 3 or 4 laptops on the side where people would sit down and use your hardware to attack your hardware, but like to extract the thing. And I will also say, was this using the faultier?
Yeah, exactly.
So what is that?
I've used the RP2040 a lot for glitching and so on. Mm-hmm. And so I thought it would be fun to build a real device that's just for glitching using the RP2040. And so it's essentially a small board that has a crowbar for doing like a crowbar circuit with a MOSFET to do crowbar glitching. So essentially just shorting the power to the CPU to ground. Then it has an analog switch if you want to, just dip the voltage slightly and so on. And then it has an ADC connected to the different to the different outputs and so on, and so you can measure. And then it also runs a full debug probe, and it's like an all-in-one introductory glitching solution. So you can essentially do fault injection attacks, and then, for example, if you want to re-enable JTAG on a chip, you do the glitch, and then on the fault here we run a full SWD probe, and we can just try whether the attack was successful.
For the audience, this sounds really stellar. Going back, for people who are not familiar, what is a crowbar was it injection?
Sure.
Can you elaborate what you mean by that?
Yeah, so essentially, crowbar is a term, again, coined by Colin O'Flynn, and it essentially means that we take the power supply to a CPU, and we use a MOSFET to short it to ground, which will, pull it down for a couple of nanoseconds, and then we release it again.
Okay.
And it's like putting a crowbar to the voltage line and just ripping it out for a very short amount of time.
Okay.
But I think the actual name comes from like crowbar circuits and stuff. And so yeah, the RP2040, like normally microcontrollers are not great for doing fault injection because you want to have very precise timing. And a microcontroller, if you do a while loop waiting for a pin to go high, you have a lot of dither and a lot of unprecision. But the RP2040 has PIO, which allows us like programmable IO, which is a small programmable state machine with which we can do like 5 nanosecond precise glitches. And so
I think Colin's book that he co-wrote with somebody, I don't remember his name off the top
Jasper.
of my head. Yeah, it's very, very Dutch, if I remember correctly. Covers like kind of that trade-off between the microcontroller versus
like an FPGA.
Something's more hardware driven. Yeah. Something more hardware driven. Yeah. The deterministic
and
trade-off.
I will say, if you do want a faultier or some glitch tags, our friend Pewter with 1-Bit Square, you're selling them in their store, right? At least in the US. And
in the US and now also in Europe. And so that was cool because we tried to make this a lot more accessible because it's just like, if you want to get started with fault injection, you might not want to, buy $1,000 of equipment or $500 of equipment. And so our goal is to just give you something that works in real life, like for a lot of use cases. It's obviously not as good as a $500 chip whisperer Husky or so. And I don't want to, compare it. For us, it's like an entry-level device to where like we do the STM32 glitch with it, the NF52. I actually do the MacBook glitch triggering with this thing and so on, and then connect it to the chip shouter. And it's all open source, like the firmware and mainly the control library was the most work. And so
I want to hear what your thoughts are, because I think you've touched upon this a little bit. Sometimes many of us, we buy, when a new product comes out, we immediately go and get that without necessarily having a lot of experience in how to use that or its applications. And what I'm hearing from you is that this is very introductory, much more simplified. is the hope that somebody gets comfortable with this and then they have much more of an appreciation and understanding of the applications for it before they invest more heavily.
Yeah,
it's kind of like it's kind of like getting like a cheaper bike before, and understanding what you like and don't like, if you like it at all, before you splurge on something that costs thousands and thousands of dollars and requires a bike fitting.
Yeah, there are a couple of angles to this for me. So one of them, I gave the keynote at TorCamp, and it was about how you can hack everything with the Raspberry Pi Pico now. And like when I got started,
we have questions about that too.
I essentially had like a Bus Pirate, like the Bus Pirate 3 or whatever it was, like over 10 years ago, a long time ago. And I was able to hack everything with that, essentially, from my perspective at the time, right? Like, oh, I could find UART, I could dump flash, this and that. And having this cheap tooling allowed me to do and become as much of an, I guess, expert in what I do nowadays. And so I want to have cheap tooling for others to do the same, right? Like if it wasn't for the Bus Pirate, for these cheap tools, I would not be where I am now, where, like I don't need to use a HackerF to measure the side channel. I have a very good oscilloscope here, but a HackerF is like, $100 versus the oscilloscope, which is thousands of dollars. And the same is true for fault injection, I think. You don't need, the super nice 4-channel scope. It's enough to have a Pico and a MOSFET, and then you can buy this as a PCB, or you can just hook it up on a breadboard and go with it. And that will get you very far. And so for me, it's kind of give people a cheap introductory way if they are just interested in exploring the topic, but it should also be just useful in the real world. And so
so you're hopefully enabling future use, just like Ian from Dangerous Prototypes got you started with the Bus Pirate. Now hopefully many people will play with the Faultier and similar, and maybe 10 years from now we'll be talking to them.
I think that's the one thing that I've enjoyed the most about the evolution within security researching and firmware in general, is that the tools used to be this huge gate, and they're consistently getting more accessible and more readily available, that it's becoming less of a factor for people.
Even the past 10 years, it's so nice.
Just Arduino of all things. I know that sounds like not great, but like to me that is such a foundational shift.
But even more quote unquote professional tool, like we were talking about 1-bit squared, the Blackmagic probe is before J-Link. J-Link's still the best, but it's really expensive. And
it's not even as expensive as it used to be.
No, exactly.
And then there's Lauterbach.
It's orders of magnitude more expensive right now. If you're using ST parts, they have their cheap ST lines, right?
Yep. Same thing with Cypress.
The Blackmagic probe, it's been around for a while, but in the past several years, it's gotten so much better, so much more useful and easy to use. And the ease of use, a lot of these community tools are actually a lot more user friendly than
they've gotten user friendly, because open OCD, like,
well, that's another story. I
said
that
but that for a while was supposed to be like freeing us from these expensive probes, but it is
better than it was
hard. Yes, it is better, but like I can tell you in the early 2000s, so hit and miss.
And even with Blackmagic probe, there's also the I think it's Buculum, I forget what it is, but it's the Blackmagic probe equivalent of the trace. Of the and those kind of things I'm really, really excited about. I want to go back to your booth at DEF CON.
Yes.
You were there.
We went all over the place.
You were there the whole time except when you were giving a talk, basically. And right next to you happened to be a Raspberry Pi, which if folks have not heard, they have a new processor out, the RP2350, right?
Yep.
And was one of the weirdest and really neat releases of a microcontroller I've ever seen, where the release was basically 30,000 or 28,000 DEF CON badges. And as DEF CON was about to start, the Raspberry Pi Foundation was like, oh, by the way, we have this new chip. and they were sitting next to you, but there was some connection there. Can you tell us a little bit about that?
Sure. Yeah. So I love the Pico, right? And so I've been using the RP2040 in essentially everything I've done since the past 2 years.
Since it came out.
Yeah, and
once again, we have questions later on.
Like for the TPM sniffer was RP2040, the glitcher RP2040, and so on. And so a couple of months ago, I wake up and I go through my emails, like still in bed, and I always get like weird emails from weird sponsorship requests, right? And I get an email that's like Raspberry Pi 2 question mark. Like, oh God, what's this gonna be? Because I didn't recognize the name, to be completely honest. And so I read through the mail and it's like, hey, Thomas, would you be available to do some hacking for us? We have the successor for the Raspberry Pi RP2040. And who is this? And so because I again, like normally when I wake up, my mailbox is full of, stupid
spam
stuff. Yeah,
but
essentially.
But you seem to have read a significant amount of this, considering you were.
I mean, there were
suspicious?
a lot of buzzwords that are very, very
question mark.
And then I scroll down and it says CTO Raspberry Pi. Wait, what? And so at that point, I was
that doesn't mean anything necessarily.
Well, but you can check at least.
Yeah, exactly. And so I checked.
Did you check the headers at least?
Yes, I actually did, because it's like somebody might be. There were too many things that are in my bubble of interest in that email.
yeah, this is some spear phishing attack.
But it's very easy to look those things up about you. So
yeah, so exactly. And so and then they, I learned that they have this new chip, the RP2350, before it was public, and we did some auditing work with them on like fault injection, which was really, really cool to be part of a chip that like
you can talk to the designer,
and suddenly exactly, and it's like we actually also knew AE was there, and also like Colin was there and also did some work and so on and so forth, and so you did some cool work there, some tried some attacks on the pre-prod silicon even, and so on and so forth. And then for DEF CON, this was kind of incidental because I was like, hey, they were like, we are planning to launch around DEF CON and we will be at DEF CON. Like, oh, really? Where will you be? And they're like, at the Embedded Systems Village. No way, we will be there too. And they said, yeah, and we want to do a bit of a hacking challenge there. Can you help us with that? And we're like, we would love to. And so essentially we teamed up with Raspberry Pi to create the Raspberry Pi RP2350 Hacking Challenge, which essentially is what I believe to be the first like bug bounty for a microcontroller ever. So we essentially put out a firmware that people can compile, install on the device and so on. And it shows how we've hidden a secret on, let's say, a golden Raspberry Pi Pico. And if you manage to extract that secret, you win $10,000. And so that's been going on for a month, I guess.
So
hopefully we'll be able to extend it. Yeah.
Oh, well, crap. I haven't even done anything with that. Okay.
And so that was really cool because people generally don't do that. And then I also contacted them. Hey guys, how about we actually build a board and give it out to people at DEF CON that is ready to be glitched, right? Like something that no microcontroller vendor would ever do, which is like we design a board. And by the way, like on the board, it literally says glitch here, because the RP2350 has a ton of security features. They have a glitch detector, and they have a boot ROM that has like redundancy and random delays to prevent fault injection and so on. Like they're really trying to build a secure chip. It has secure boot, this and that. It's really nice. And we thought, hey, like let's give to the people just a board that you can directly use to test for attacks. And they were like, yeah, sure, let's do it. And so we like literally last minute produced 100 boards for DEF CON, which have like, SMA on the side, and you can disconnect the internal regulator so that you can feed in external power and glitch it and so on and so forth. We have like SMA on the clock so that you can do clock analysis, glitching, alignment, all that kind of stuff. And Raspberry Pi was actually awesome to work with. And then we kind of had this combined booth at the Embedded Systems Village. Like one on the left was Raspberry Pi, us on the right. And then we gave like demonstration on the glitch detector, and you could chat with the chip designers. So it was a lot of fun and very cool, to be honest.
Can I going back to like before you guys got to DEF CON per se, and you're in the room, you have Colin, and you guys are working on how to glitch this because that's what you've been requested to do. I guess for somebody who's never, for someone who's maybe working on these products, trying to get a new chip out into the world or working on their own product, what are like kind of some baseline EFI related things that we should be checking for that we can do on our own?
That's kind of the difficult part, right? Like, so the problem is that, let's say you want to protect against voltage fault injection. Almost no chip currently has protections against it that doesn't require an NDA. I think the RP2350 is like one of the only ones that has active countermeasures.
Yep.
Like glitch detectors. And so if there's a bug in the boot ROM that just like on the STM32 lets you, bypass anything that you could potentially do in the firmware, then you are just, lost essentially. But then from a chip vendor perspective, they can do a lot of fault injection testing. And I mean, in general, they already do, right? Like they characterize the power supply, they check, does this run stable and so on. So
either in simulation or early bring up, into
but
validation and verification,
yeah, exactly. And so there's a lot people can do, and if you go to the length of building custom silicon, you probably do a lot of that stuff already, because you need to know, like, if your power supply has ripples, will it affect the chip and so on. But by now, like, you can test the susceptibility whether a chip is glitchable very, very easily, right? Like, you can just buy a chip whisperer, put an endless loop on your chip and try to break out of it. And what was really cool about this is that they were like super open and super, like, it felt to me, and I'm not getting paid to say this or anything, but it sounded to me like they want to see this chip hacked so that they can make a better one. And I think that was really cool to see.
Yeah, and
that's a different perspective,
because this is an official. It's like $10,000 bounty for anyone. So if you explain it, if I understood what you explained correctly, there's source code online. You download it, you compile it onto your own RP2350. If you're able to extract your own secret, then if you're able to reproduce that same method on a device that you did not have access to beforehand, then you can get the bounty.
Yeah, exactly. And so the idea is the current scope is on like essentially bypassing secure boot. And then, maybe it will be extended for other types of attacks in the future. We'll see. But this is kind of where we're at the moment. And it's been pretty cool. I saw a lot of my friends trying to get at the secret. And so a couple of people made me pretty nervous, to be honest.
Well, I mean, They did reach out. I mean, the Raspberry Pi did reach out to some of the best well-known folks. Like, they did their homework. They're like, hey, who's doing this? Who should be doing this? And then they go to DEF CON, which everyone else is at. And then you basically Snerd Niped hundreds, if not thousands of hackers to be like, hey, I bet you can't do that. And like, this is the title of our last show, right? It's like they told me I couldn't do it. And then you were like, well, they said I couldn't do this, so I'm going to do it.
Yeah.
So I think that was a pretty cool way of going about it. And like you said, this is the first silicon company we know of that's doing anything like that. Most of them are just like, hush, hush, we have security, but we can't tell you about it. Or if we tell you, you can't tell anyone about it.
Yeah, we need to lock down your souls in some way. Yeah.
I mean, we were talking about TPMs. If you try to get the data sheet of a TPM, good luck.
I mean, every single one I've ever had has had, like, it has my email address, like, as the watermark across it. Like,
classic.
Classic.
And so just to close out, we talked about DEF CON. How many times have you been to DEF CON?
Oh, I'm not sure. Quite a few.
A few.
I'm not sure.
You have a home already set up in Las Vegas.
Luckily not, but I think I've been to more Black Hats than DEF CONs. But DEF CON I've been.
Is there a big difference for you?
Massive. It's so Black Hat has changed so much into so much businessy stuff, which has its own values as somebody who runs a small company. And then DEF CON is just like with a new location. I feel it used to be I didn't really like it when it was split across hotels, because it was impossible to walk somewhere and meet someone. Like, you would say, hey, where are you at? I'm at this place. And then you get there and they are already like,
they're gone
completely, different, in a different direction. And what was really amazing this time was like running a booth at DEF CON, and like that gave me a very different perspective to the event. Like, that was a ton of fun. Like, I don't think I've ever had that much stress and that much fun at DEF CON. So but I think it was also like we had 2 people, and so suddenly like seeing your logo at like DEF CON as a booth, and then next to Raspberry Pi, and then everyone is super nice, everyone is like super constructive on like sometimes stuff didn't work on Windows or something. They're, oh yeah, but I figured it out for you. Here you go. And it's like an amazing experience for us. Afterwards, we were dead, and so we just like tweeted a picture of us being passed out on our tables. But it was a ton of fun.
So what you're saying is you accidentally, and I'm going to use Alvaro's terms, Snerd Niped.
Nerd sniped?
No, you said that a little.
Oh, I said Snerd Niped?
I was like, did something change?
That's a show title.
It could be.
And so from times that you didn't have a booth, what was kind of some of your favorite parts of DEF CON when you weren't totally stressed out of your mind?
Oh, good question. I think I mainly enjoy having so many of my friends be in the same physical location, and so you can actually meet people that I literally only meet once per year, or because we miss each other so often at DEF CON, it's like every 2 years we might manage to see each other.
Yeah.
And then like a lot of the booths that are now, I feel like they are less commercial again. For a while, I felt a lot of the booths were too commercial at DEF CON. I mean, there was still the gigantic,
the size of
the VR one was really maybe a little too commercial for me, but interesting.
I haven't visited any of them because I was literally at the booth.
Yes, you were bound
at the talk. So I was, but otherwise, it really felt like it was having everything in one location was cool. I hope it will kind of manifest, but I think going for DEF CON, I think people should bring something to do and to show. Like DEF CON is this gigantic show and tell conference. And I think a lot of people make the mistake of going there to just look at stuff, which I think is the wrong perspective. Yeah. Like now that I've given talks at DEF CON, but now this year with like bringing all the hardware and so on, it was just so much fun to engage with people and, show and share. And then people bringing their own PCBs. And like, I traveled there with kind of heavy luggage, and I got home with even more luggage because everyone kept gifting me their project PCB and so on. And so like having this, I give you this, and then they give me something different that they've been working on has been amazing. So my tip is
bring an extra suitcase.
No matter how simple your side project might seem to you, like the person that will be super interested in it,
you'll
will
probably
be at
meet them there.
Yeah, exactly.
Yeah.
And so that was really awesome. And then
I felt like that was a mistake that I made, is I like, outside of having stickers, which if you find me, I will give you a sticker, but like I just felt like it wasn't enough. I just didn't have time to get it together, and you're absolutely right.
Yeah, and don't get like dragged into your schedule, right? Like just try to enjoy your time.
It's impossible.
What looks like fun, go there.
That's crazy. Yeah. Well, you can't find everything.
my first 3 DEF CONs, I was just in a contest the whole time. And that's another thing. There's so many now very cool and accessible contests that you can just show up, and you might not need any hardware. You might just need a laptop, or you might get like some sort of hardware to play with. But a lot of people go to DEF CON and they do this just one thing. Like we talked about the bomb diffusal challenge. We had the box episode a few years back. And some people just go and try to diffuse that challenge the whole time. Or there'll be Embedded Systems Village, I think, had a little CTF. People go and just work on the embedded CTF or the industrial control system CTF. And then you just sit there and meet other people that are working on it and you'll miss all the talks, and that's okay. Most of them are recorded. You can catch them later. Yep. I only ever go to talks where I know the person that's speaking, but because I know it's going to be online later. And so there's so much fun. so many
and
fun
also
things to do.
Like some of the villages are amazing, right? Like the embedded systems village was amazing to us. They've been so nice in hosting us, and everything was like they took really good care of us. Like we kind of felt it was really cool how they really like were also making sure like nothing becomes too commercial, like it's in the spirit of DEF CON and so on and so forth.
Yep.
And I think that's really important, right? Like we don't want to shill a company. We want to contribute something to the event. And I think that was
you're literally
nice.
just teaching people for free. Like and I was like, that's fair. Like if you want more, we have courses, but like you're just sharing information in the most wonderful way.
Yeah, it felt like there was a pretty strong continuity between the hardware embedded systems and IoT. Maybe was kind of like a little more, not commercial, I'm not saying that, but like was maybe a little bit more maybe advanced or.
I mean, there's all levels, right? Like
no. But it all kind of flowed together
Yeah.
and had a consistent culture around it.
Yeah, you have that like the DEF CON CTF, which is like the baddest of badass, like the most hardcore one, and you have the super like capture the packet, right, where you're listening to wireless stuff. You have the ham radio. You have it's just a little bit for everything. Or social engineering. Don't need computers at all. Hack people with your mind.
Yeah. Like the other events, right? Like the suites that are full of people that give self-organized talks and so on. And our plan was like on the last night, we just go to the CTF party where all the CTF teams are, and we'll just all the stress is gone and we'll have a good time. And then that one got raided by the hotel and we got thrown out. And then we went to the next party and that party got shut down too, just as we arrived.
Was the hotel? I guess there was. Is it One World Resort? I can't remember.
No. This was not that one.
No.
But I heard the story of what happened, and I would say that we got deservedly kicked out. So.
Oh no, this was like it was at least 100, more than 100 people, I think, in there, easily.
In one room?
No, it was like top floor suite. Like
okay,
I don't know how many rooms there were. There was a lot of rooms.
It was crazy. Yeah,
it was fun.
Sounds lovely. So, I mean, this is going to be a very naive question for pretty much everybody here, but, one of the things that was kind of interesting in Las Vegas is that there's still kind of a perception of hackers and DEF CON that kind of comes across as fearful. Yeah. What is the biggest misconception you feel about DEF CON and hackers? Or has it really evolved such that people feel like it's mostly benign and just snerd niping?
Yeah, I think people mainly get snerd niped into random stuff, but I think I mean the fact that the sphere wasn't hacked shows that people are more benign than but I think it's overall I don't think people accept like the security profession as such. And I mean also DEF CON has changed a lot, right? Like there used to be a very strong, like let's say spot the Fed and whatever, and now it's like
the Feds are everywhere.
Well, the Feds are in this big tent in the middle.
They were giving it like one of them was giving a talk for held a small rally for Harris during that time.
Yeah, there's political stuff. Well, that was not at DEF CON, but around DEF CON. Yeah.
No, not that one. Not the one that was in the stadium. No, earlier.
No. But it was not like DEF CON sponsored.
Yeah.
Officially, no, but it was.
Oh, there's so much unofficial stuff.
Yeah.
But which is
they did have a
part,
stage.
Right? Yeah. So I don't really. Yeah. I don't know. I don't know if there are misconceptions. I felt like everyone was pretty nice. And the Uber drivers didn't seem too annoyed and so on.
They knew about it.
Yeah, exactly.
They knew about it.
It was kind of funny because some people preferred the Black Hat crowd and some preferred the DEF CON crowd because like apparently like very different experience in tipping and so on. So
what is the difference? I feel like the big difference, my sense is that the company's paying for this one and the company's probably not paying for this other one.
Yeah.
And you can guess which one.
But I think the people are friendlier on one.
Yeah, I would say. Well, Black Hat is UBM, isn't it?
Yep.
Yeah. Which also does the Embedded Systems Conference.
Which there's one in October in Austin. Oh no, that's Embedded World.
Yeah. But like historically, like the Embedded Systems Conference Alvaro, that you and I know. No,
that's
all run by them. Yeah, that's all run by that media group.
Yeah.
And so it definitely, to me, has that flavor of that.
But both of them are so large now. So I would also strongly suggest that you check out some, smaller hacker get-togethers. Like TorCamp was amazing.
TorCamp.
TorCamp is one of my favorites. I was so bummed I missed it.
I was bummed for you. I was surprised.
Because I missed Chaos Camp last summer because I got COVID. Like literally when I landed in Germany, I tested positive. And
oh man!
And then at TorCamp, I was at a teardown, a cross supply teardown in Portland, and I was going to drive up to Washington to go, and then I got COVID again.
Was that at which one did you get it at the reverse engineering meetup that the last?
I went to the Mountain View reverse engineering meetup, got COVID, and then
I mean, I wore a mask. I was fine, but
no, I mean, it's just bad luck, right?
Yeah, I know.
It's can't get away from it. But speaking of other conference, it's not a small one, but CCC
in Hamburg.
In Hamburg how big is that one? Because I really want to go this year.
Oh, it's big, but it's fun. Really big. It's different. Very, 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 very different to DEF CON is what I would say. Very far more non-commercial than DEF CON, and DEF CON is already like low on the commercial end. It's very very makery, very political, like very, very political compared to DEF CON.
I have questions. Would you say it's kind of like, when I think of like hackers and like particularly in the early 2000s, I think of, this is going to sound like really going to date me, electro hippies?
I mean, I don't know how to put it. Electro hippie, but there's a lot of political talks because the CCC has been traditionally like a very political organization.
Yes,
but like you can still find your hacker folks there, your maker folks, and so on. And it's back in Hamburg. It used to be in Leipzig, where it was very trade fair sized rooms, which was very. It had a very different vibe there, and now it's back to like a more like the roofs are not 10 meters high and so on.
Not like the DEF CON floor this year
and so on. Yeah, and it's very, very spread apart now, and you can actually get lost somewhere, which is makes you just discover different aspects. So.
I'm gonna try to make it over this time because I've been meaning to, and this time my schedule actually works out. So.
Well, how many people how many tens of thousands of people are we talking about? Are we talking tens of thousands of people? Because that was always my impression.
That's a good question.
Because the Chaos Camp was like 6,000. So, wow. And that's got to be a lot smaller than the conference, I assume. Or Congress.
Yeah, the conference is like, I think it's like 15,000 people.
Okay.
Still
that
pretty
is
decent.
smaller than
well, DEF CON was almost 30, yeah.
DEF CON was...
But it's Vegas.
Enormous, yeah.
Yeah. And yeah. Also, my tip for DEF CON is get some good food off, like somewhere that is not the
God, no. Yeah. Okay. So what did you have a top food place that you went to?
Oh, that's a difficult
I guess this
one.
is like top survival tips. So let's start with food because I love Vegas for food.
Yeah, Vegas for food is great. I had amazing sushi, but they still managed to screw us over a bit because we were mostly vegetarians, and so we asked the waiter, just give us random food for vegetarians mostly, and then a bit of fish.
Understand that.
And we repeated this just probably 5-6 times, and then he brought $400 of fish and $300 of other stuff. So we had a ton of fish, which most of us didn't eat. But the vegetarian options were amazing. So sushi is amazing. Then off strip, there are just very, very good restaurants.
Where did you go for the sushi?
It was at Resort Worlds. I don't know the name of the place, but it was like at the hotel that kept, searching
for Celia logic analyzers.
I was actually in there, and when you
what
entered the room,
weird thing to look for. I mean, honestly.
Yeah. The TV had a warning on it. Like I entered the room, and the TV had a warning which was "Hi Thomas, because of a hacker conference, we are searching rooms and so on for your own safety." And like my room looked, sketchy at least. So
I'm teaching the hackers. Thank you very much.
Yeah, I have things offline to say about that, but also first. I don't think it's necessarily a first because I've heard about these
there's been
others,
but this was like the first time it was officially like publicly like we're doing this, and because after the shooting they would search rooms and stuff.
Oh, I get that.
But this time it was targeted specifically to people who booked with a DEF CON booking code. If you had booked Resorts World on your own, they would not search your room.
You mean I never got in on a booking, so I'm like so far away and had to take the tram in and sweat?
It was very weird, and
But anyway,
but I hear like One Worlds doesn't have their hotel keys that are hackable, so
that was the talk after Thomas's with Leonard and Ian Carroll, I think.
Yeah.
We'll try to get him on as well.
Yeah, it was pretty good. The amount of time it took.
Yeah,
before they could talk about it was impressive.
That was something else.
Yeah.
But anyway, I think we've taken up way too much of your time.
Oh yeah. But my final Vegas tip though is like take two days or so afterwards and actually enjoy the non-Vegas parts. Like go to Red Rock, go to Valley of Fire, go to Zion. Those will be the best places to recharge after a busy conference.
And you want to recharge. Like I'm the crazy person that went to work on Monday.
I didn't even do that.
Party Sunday night. But
I'm just like, Alvaro, you are so young. You're so young.
Oh no, I don't do well at night, but I was like, yeah, why not?
I specifically stayed home on Monday because I just wanted to see whether I developed any symptoms.
Yeah.
Like I'm just like, okay, let's just find out.
I mean, I work from home, but still, I know.
Yeah.
It worked.
Yeah, I self-isolated for a week after DEF CON because
because I saw my Mastodon just go DEF CON COVID, DEF CON COVID. I'm like,
well, I mean, there's other diseases too, right? That like
there are, but I didn't make out with anybody at DEF CON.
There's always, we used to call it confluenza, right?
Oh,
like
yes,
where
yes.
you go to a conference and then you're just sick. Like colds, flus. What happens in Vegas does not stay in Vegas.
I mean,
not anymore.
I mean, I got my wristband for Darknet Diaries, but I don't think that constitutes.
Oh yeah, we ran into Jack.
Yeah, that I think his crew got taken out pretty heartily by COVID.
Oh no.
Oh
yeah.
Well, yeah. I mean, just air.
It's just.
Yeah, I think I lucked out because I had recently been sick. So
yeah, I think so too.
But I got my updated shot
Booster?
scheduled. With the new.
I haven't gotten. I don't know when it's local to me, but the
new model is out on Friday, so I'm gonna go get that one in my flu shot.
The CDC is dropping a new cipher. New cipher.
But anyway. Thomas, thank you so much for joining us. This is always fun to catch up with you. And It was great to meet you in person finally. But now we get to share that joy with everyone else.
Absolutely.
Awesome. Yeah, thank you for having me.
Is there anything that you'd like to say to the audience? Anything?
Or can people find you online? All the good stuff?
Yeah, I mean, so if you want to find me online, you can find me on YouTube at Stacksmashing, infosec.exchange if you're into Mastodon. Again, just Stacksmashing. And otherwise, again, if you're interested in learning fault injection, we have like a small free course on that on our platform, hackstreet.io. And otherwise, if you want to contribute to some of the open source fault injection stuff, I would love to see that. And please don't how did you put it? Snerd Niped?
Snerd
Niped.
No, please keep it coming and try to nerd snipe me into whatever.
Maybe next time it'll be something that somebody said and you're like, wait, what? No, I have to do it. And we'll have links to all these things as usual, and all the things with like T8012 and all the good stuff. Asahi. You can find me at Alvaro Prieto on Twitter, at Alvaro on Mastodon social, I think, alvarop.com, and Jen.
Rebelbot Jen on Mastodon, and anything else for the most part. I think I'm under InfoSec on that one.
Yeah, InfoSec Exchange. Yeah.
Did you also mention the unnamed show on Mastodon?
The show has we're on Mastodon. Oh no, we're on InfoSec Exchange.
Yep.
On Twitter, on
YouTube.
Unnamed. No, I'm ready.
Unnamed_show. Yeah, I'm just gonna comment really quickly that the fastest way to find us is gonna be on Mastodon. We're really not doing Twitter
like we
as much, times. But just to be honest, or X or whatever it's called now. But we're like the Brazilians. Not really gonna go there.
We'll still post stuff on there, but we're not checking the messages very often.
Yeah. And of course we have a YouTube. So if that's the way you're listening to us, feel free to comment on there or reach out to us to let us know that it's actually useful for you. But we'll just keep doing it.
Subscribe.
Yes, you can like and subscribe.
Sorry, yes.
And yeah, email show@unnamedRE.com. That's probably the fastest, the most reliable way to get in touch with us.
Especially if you want to send us spam.
Yeah, if you want to sell us a conference attendee information, we get a lot of those.
We get it all the time, but you know what helps? What helps? Question marks in the subject line.
4 question marks.
We wanted to shout out a couple of our Patreon subscribers because we haven't done this in a while.
Yeah, probably not. No.
Probably, but it's been a while. So we got TJ McConnell, Scott, Infernal Possum, Thomas, with a very lovely Polish name, Daryl Davison, Simon Clemenson, Mark Turner. I think we talked about Scott Hansen last time we did this.
Thank you so much for joining us.
Thanks for having me.
Thank you.